So we'll do that after this, and we'll do quadratics, we'll do discriminant. There'll probably be just questions on discriminant in the exam, to be honest. No. Extension. Extension, there will be questions using the discriminant in the extension. I can almost guarantee it, right? So I will teach it to you, don't worry. So we're in extension 1, so in the OneNote, that's extension 1 there. And we're starting curve sketching. Okay. So there is the syllabus content we're going to get through this week. So today we're going to do the first dot point and the third dot point is my plan. That's curve sketching is the broad topic, I would call it. So today we're going to do reciprocals and we're going to do absolute values. We're not following the order of the textbook because I think these are the two better places to start. They're easier. And then probably tomorrow we'll do the second dot point, and then in the last lesson on Friday we'll do the last 2 dot points is my plan.
We have 2 lessons tomorrow or Friday?
I think we have 2 on Friday. Is that right? Oh, it's 2 tomorrow. Okay. So we'll probably do most of it tomorrow then. Absolute values. So before we actually cover the syllabus, I just wanted to go and do a little bit of a review on transformations. Okay. So there is a link here. If you click it, it should take you to this, right? Now, here I've got just a random function, basically just designed to be able to show off all the different transformations. So that's going to stay red. And then in blue, we're going to have fx plus a. So what do you think is going to happen? What type of shift, Anna, is that a going to cause? Up or down? So if I make a positive, hopefully everything will move directly up. And it does. How far up does it move? Whatever a is, right? And if once a is negative, it goes down by the same amount. Okay. So that's where you've got all of fx clustered as one thing, and then plus a number at the end. Okay, so that's number at the end tells you up and down. Whoops, don't really care about that one anymore. So now we've got f bracket x minus b. So what type of shift is that b going to be? Left and right. So if I make b positive, is it going to be left or right? Positive. So if fx minus 1, which way does that go?
Right.
To the right. Remember, it goes the opposite to what you think. So fx minus a positive number will go to the right.
So is this still within like functions? This is still like,
yeah.
So whatever connected to the a, whatever's connected to the x will move to the right.
Yes, and you have to be able to put it just in brackets with just x.
So, and if it was a negative number, it would essentially be fx plus.
Yeah, in this case, it would be like fx plus 4. We'll go 4 units to the left.
So what if it was f2 and then in brackets 2x minus? Does that still do the same thing?
That combines 2 things, and we'll do that later. Okay, but in terms of the left-right part of it, you have to take the 2 out of a bracket.
Yeah.
So say it was f2x minus 2, you'd have to go f2 bracket x minus 1, so it would be shift 1, not 2.
So you can just try and divide the other value back.
Yes.
So x needs to be alone.
Yes, it needs to be just x plus or minus number. So now we've got p of fx, where p is just another number, so p times fx. What's going to happen when I make p a big positive number?
Squish. Oh, squish together.
Positive, big positive.
Squish.
Where's the p?
Oh. P's in front of x.
It's in front of f. It's in front of everything. So what's it going to do? Bigger meaning?
Like wider. Narrow? Expand.
Not quite. Let's do it and see if we go R.
steeper. That's steeper.
That's what I meant. Squish.
Gets steeper.
Yeah.
Doesn't get squished because where does the curve meet the other curve? Where are they the same?
Same place. They're the same X.
What is happening here and here and here?
Isn't it like a
Why are they the
it shows
same
like
there?
steeper?
Because Y values are changing, but not X.
What's the y value here? 0. What's anything times 0? 0. So it's steeper, but fixed at the intercepts.
Parabola, no.
I mean, this could be anything is the point.
But like if it was 3x squared.
Yes, as opposed to x squared. Yep.
So technically you get like the slope would decrease to if you had minus p.
The slope will decrease if p is between 0 and 1.
Right.
So for small p but positive p, it will flatten.
So steeper if p is
Bigger than 1,
and then
flatter if p is between 0 and 1.
What if negative?
Yeah, we'll get there. So what will happen if p is just negative 1?
It'll like reinvert
It'll
itself.
just flip. Yeah.
Flip, right? Nice fish shape. Kind of.
Well, it'll be in, but like if it was a number that was like not 1, like negative like 7, it'll just get a bit like steeper.
It
again,
flips
so it gets steeper.
And it gets steeper.
Yeah, okay.
So big negative means flip and steeper. So the way I like to think about all these things is, what am I doing to the y values? Well, I'm multiplying them by a big negative number. So they should get bigger in size, but they should flip. Okay. What's going to happen if I multiply by a small negative number? Smaller in size, but flip. So it'll be under the axis, wherever it's above, and above wherever it's under, but it will be flat comparatively.
That's between 0 and 1, right?
And then obviously 0 is just like trivial. It just kind of, see if I can actually land on 0. The function is then 0, right?
So the graph only flips when it reaches -1?
No, when it reaches any negative value, but it's a pure flip. Like it's a symmetric flip at -1. So you should be thinking about negative fx is just a flip.
Okay.
But then you can have like -2 fx or -7 fx.
Yeah.
Wait, what's this about the 0 and 1 thing?
so where it's between 0 and 1 it flattens.
0 and negative 1.
This
right?
is in our exam.
No,
right?
0 and 1.
Well,
What about when it's negative?
when it's between 1 and -1, it squishes. But if it's negative, it's also flipping. Does that make sense? Because think about it in terms of absolute value first. So if the absolute value of the number is from 0 to 1, it will be flatter. And then if it's negative, it will have flipped. Whereas if it's positive, it's not flipped. It's just squished.
So the graph is flat.
0 and 1 will
This is our test, isn't it?
-1.
Yeah, theoretically.
Yeah.
I mean, I'm not going to explicitly say P, what does P do if P
No,
is?
like graphs.
Yeah.
Yeah. So it's the same.
Okay.
0 and 1 it's flipped. It's negative.
What about f of qx? So now the x is being multiplied by a number. So what's going to happen when I change that? So that's going to be the accordion thing, right? So let's do big Q first. What does big Q do? Squish or stretch?
Oh, so it's not.
It's gonna
big Q.
Don't doubt yourself. I'm just asking. Squish or stretch?
Right.
Big Q, stretch? You think squish, Caitlin?
Oh, I did.
Squish. So the idea is that if, let's say Q is 2, right? Before, it took 10 units for X to get to 10, right? Now for QX to get to 10, it only takes 5 units because Q is 2. So everything changes quicker, which means everything is compressed, right? The change happens quicker. We're kind of starting to delve lightly into calculus here, right? So the bigger it gets, the squishier and squishier it gets. So between 0 and 1, it's going to presumably stretch.
Then it changes once you get past.
What?
Can you go past -1?
Yeah, I will. What happens when you go into negatives?
It does the same, but it flips up.
Wait, what do I write
What
down?
axis?
That. Wow.
Y-axis, yep.
Yeah, what does Q do? Or what do I write down?
So here's -1. Oh, actually, here's -1. The orange one now is -1.
Yeah, flips on the right.
So f of -x just flips it on the x-axis. So if you remember, like, do you remember drawing e to the x last year, or 2 to the x?
Yeah.
Yeah, so when you draw 2 to the x, it's like that, and when you draw 2 to the -x, it's like that. It's the same thing.
What do I write down? So, what does Q do?
Q, I would say it's a compression factor.
And
Or you may like to use the word dilation, because we'll use that
The
later.
larger the Q value, whether negative or positive, the
More compressed, yeah.
The
So
larger
big
the-
negative Q, it's flipped in the x-axis, but it's really compressed. I would encourage you to, tonight, go and just play around with this for a bit, because things are better understood if you do it yourself, right?
So, and if it's negative, it just flips it on the
Will
x-axis.
all of those be on OneNote? Like all of them? Like,
This is just a website that's just saved.
Okay.
Oh, right, yeah.
So the larger the Q value, the more compressed.
Yes,
Well, technically, like -7 is smaller than -1, so it's like.
yes, but you're thinking about, so first you think about it in terms of size, and then you think about it in terms of direction.
1 and -1 0.
That's what throws me off.
So
Oh my god, that.
But it's stretched when it's between.
the last one we'll leave for today, and we'll come back to, okay.
This is literally.
Why? Okay. So now we're going to start like new syllabus stuff. So reciprocal functions. So reciprocal is 1 over, right? So if I think about a function fx, then the reciprocal is 1 over fx. Okay, everyone happy with that? So what I really want you to think about whenever you're doing this topic is that fx is a number and it's a y value. Okay, and you're going to sketch it, you're going to sketch y values, and they're going to have numbers, and you're going to do something to that number. So the important things for reciprocals are, if fx is 0, then what happens to 1 on fx?
It's you can't do that.
Undefined, right? It's infinity, which means for a graph, there's an asymptote. Yeah, that's
Can you reset it? Yeah.
the definition of an asymptote. 1 over 0,
Yeah.
that's an asymptote, right?
So undefined equals asymptote.
Because it's, so if you have a square root and it's negative, does that have asymptote?
No, because that's not dividing by 0. The only time you get an asymptote is if you divide by 0.
Okay.
Okay, so undefined asymptote. So you don't, like, 1 over 0 is undefined, whereas the square root of -2 doesn't exist,
Yeah, okay,
is what you say, until you do extension 2.
Wait,
Okay.
so it doesn't exist.
Yeah, it's a thing. So if fx is +1 or -1, it turns out, then 1 on fx is just the same as fx, right? 1 divided by 1 is 1, and 1 divided by -1 is -1. Okay? So if fx is plus or minus 1, oops, then fx is the same as 1 on fx. Happy with that? I'm just thinking, don't worry, like there's a lot of notation happening. Try to separate yourself from that. All I'm really saying there is that 1 is equal to 1 divided by 1. -1 equals -1 divided by -1 is all I'm really saying.
What does fx stand for? Like, how the function is that?
Yeah.
Like, where will the numbers be? Like, in the x bracket?
It's,
X is a variable, so X
Yeah,
will take
so-
every number.
But they'll
Yeah,
give us, they can't just give us that and be like, what?
but it'd be like this.
so what was that? And then fx equals 1 over.
He's literally just saying.
Yeah, okay, that's
So it's
okay.
just reciprocal.
Yeah, that's fine.
1 over 1 equals 1, and 1 divided by 1 is 1.
Oh, that's like a.
Okay, and we'll start to think about what that means for a drawing, a graph in a second, right? So as fx goes from 1 down to 0, then 1 on fx, I say here, increase it as rapidly from 1 to infinity. Right? So what do I mean by that? Well, when fx goes from 1 to 1/2, then 1 on fx goes from 1 to 2. And then as it goes from like 1/2 to 1/4, which is half that distance, it goes from 2 to 4, so it goes twice as far, and so on. But basically what he's saying is there's an asymptote, right? So this here is basically saying there's an asymptote.
So infinity is kind of representing the asymptote.
Yeah. But the fact that you never actually hit that asymptote tells you that infinity is a concept rather than a number.
Yeah, I don't know what to write down.
Yeah, either.
You don't have to write anything yet. You're probably better off doing the examples and then writing your own thoughts down. And as a general rule, if fx is decreasing, and I should really have absolute values there, but that'll just make you more confused, I think, then 1 on fx is increasing. Okay? So basically it's the opposite. So if your original is going to go up, then your reciprocals are going to go down.
Wait, so
And then the opposite is true as well.
what does that mean by that?
So all I'm saying is that if fx is decreasing, so as you draw fx, if it's doing that, then 1 on fx is going to do that. It's going to increase.
It's decreasing towards 0. Or
Or just getting smaller at all. It doesn't have to go to 0, but if it gets smaller, then the reciprocal will get bigger.
On the
It makes sense if you
y-axis?
think about it.
Yes,
like,
everything is in relation to the y-axis.
It makes sense if you think about it in like
yeah.
exponential.
Everything here is hyperbolas, basically, and exponentials, yeah.
it'll be like, you know how you say fx and the reciprocal is 1 over fx? Isn't the reciprocal like the negative switch as well?
No, that's the negative reciprocal.
Oh,
Yeah. Yeah, and then the opposite is true. So if fx is increasing, then 1 on fx is decreasing. So let's try an example now. So let's sketch 1 on fx, given that that is fx. So let's do this, and we'll start by sketching fx, right?
so what?
So fx is this, so I can factorize that to be x plus 3, x minus 1. And whenever you're doing these, you're always going to be sketching the original and then using that as a reference.
Oh, so you have to sketch the original.
Yeah. And in the exam, you'll probably get like a separate sheet of paper that you'll draw your answers on with things there for you, kind of thing.
Yeah, well, we have like graph paper.
No.
You just kind of have to make a scale yourself.
You have to make
What I'll probably do is I'll probably be drawing the graph
For like
on a computer and then giving you that on a separate sheet of paper to sketch over the top of. Start by drawing the parabola, right? So it goes through plus 1 and 3, minus 3, and the vertex, we actually do need to know the vertex, is at x equals -1, f -1 equals, how did I know it was at -1?
Because in the middle of the intercept.
It's in the middle of the intercepts, yep. Or it's negative b over 2a if you want to think that way. Either way is fine. So -1 is 1 minus 2 minus 3, so that's -4. Okay? Those numbers are all important. So then I sketch my parabola, trying to be relatively accurate today. Try that again, I think.
You need to know the y-intercept?
Yep.
So it's minus 3, is it?
Yeah.
Wait, isn't minus 1 minus b over 2a?
Okay, so I'm going to sketch the reciprocal. And this is basically where we come up with a set of rules that we always follow.
Okay, great.
So the first thing we do, what's the most important thing with our reciprocal that we found before?
You put the 1 on top.
Yeah, and where was the biggest kind of problem area?
When it's got 0.
When it's 0. And what happens when it's 0?
Because it's asymptote.
We draw asymptotes in.
So you just know How do you know that that's the asymptote?
because I'm going through where it's 0. Right, so if fx is 0, implies asymptote.
But if x is 0, like say you've got 1 on x squared plus 2x minus 3.
Yeah,
Yeah.
that's what we're sketching, right?
Yeah, we've drawn that. So, yeah.
So fx is 0 as an asymptote. I'm going to rub this out, so don't draw it.
I'll draw it.
No. The next thing that I'm going to draw. But basically, I know. So here, I've got a very small positive number. When I flip that, it's going to be a very big positive, so it's going to be up there.
Can you explain how you did it? How did you get to those red lines? How did you?
They're my asymptotes where fx is 0.
How do you get to that?
How did you get
Because I can't do 1 over 0.
Yeah, but you can't
So
do
you're
zero
saying
y.
fx can't equal 0?
Yeah.
basically.
Yeah, so why just 1?
Why just 1? What do you mean?
Well, you were like 1 over 0 is undefined, so it's 2 over 0.
Oh yeah, but my goal here is to sketch 1 over 0, 1 over fx.
Could you alternatively just do f, like, if
Hold on.
f?
So you have to make sure
Right.
f of x isn't 0.
Yeah.
And you just look at
I know that 2 over 0 is undefined and whatever, but all I'm aiming to do here is sketch 1 over fx, right? So what I'm doing is I'm saying, what are the values of fx? And then what does that do to 1 over fx, right?
Okay.
So if fx is 0, then 1 over fx is undefined. If fx is 3, then 1 over fx is going to be a third, for example.
especially whenever the y axis is 0.
Yes.
So where is the y axis is always going to be that asymptote.
X-axis, yeah.
Yeah, the x axis. So the
Yep.
x-intercepts.
Yep.
But didn't you just say, wait, okay, so 1 over, why are you drawing the asymptote at 1 over, like, on -3? Because then it wouldn't be undefined.
That's
This
the
is the-
x value is -3. What's the fx value?
I don't know, I'm really confused.
So fx is 0 there, isn't it? So this point here has coordinates -3, 0, right? This is x and this is fx.
So you're just, oh, okay.
Why is that fx?
So you're just trying to
That's the
find
definition.
points where y equals 0.
Yeah.
Okay, that.
Oh, okay.
Remember that for us, fx and y are virtually always interchangeable, right? They basically mean the same thing.
Okay.
Yeah.
Oh,
If-
so fx and y are
If I'm turning it into a graph, I am basically saying that y is fx, right? And I'm sketching y equals fx.
So you could just say y equals 0, 0.
Yeah.
Like, so.
Okay. So when it's 0, there's an asymptote. Small positive values are going to lead to very big positive values when I take the reciprocal. 1 over 1 million equals 1 million. Sorry, 1 over 1 over 1 million, you know what I mean? Very big positive values are going to lead to very small positive values. So I know that my curve looks like this. Right? I'm going to draw it again because there's one other thing I need to think about, which is this bit here. This bit's quite important. This is where you earn your marks. So you must say where it's 1. So I'll put, if it's not already on the graph, you just put it on yourself like so. So I'm going to call that 1. I'm going to call that -1.
Is that just an asymptote?
Wait, why do you have to do 1?
Because when the graph is 1, the reciprocal will also be 1. So in other words, my reciprocal graph should pass through that point there.
Also, it should go through that.
Yeah.
It doesn't have to stay above that.
No, it's not an asymptote.
Yeah.
Yeah. It's just a line to show me where 1 is, right?
Do you have to put that in your thing?
I would, if it's not already there. Yeah.
So, what? Can you just tell me why we graph these little horizontal ones?
Yes, I should.
Why are we what, sorry?
Graphing the horizontal ones?
Because that's where it's 1, and the reciprocal of 1 is 1, right? So since I'm drawing the reciprocal, when it's 1, it should pass through the original.
Oh, because it would just essentially be y equals 1 or y equals -1.
Yeah, yeah. So the
So it
same
should
thing,
always cross the 1 line.
yeah, so it should happen over here as well. sometimes you make
So is
your
the
life a
one
bit
line
harder
kind
than
of like a guide
Yep.
as to the like, so where the one line intersects the blue.
Yep, your red should also go through.
Got it.
Yep.
So you're trying to kind of find a point of 3-line intersection and then draw your hyperbola off that, or whatever it is.
Yep,
And it always hits it where the blue line hits the one.
yep.
Okay.
Okay, so there I've got my right branch and my left branch. And now I've just got to do my middle. And after a little while, you start to notice that basically all these curves look exactly like this. 2 hyperbola bits and a parabola bit in the middle. What does that mean? Well, you're about to see, hopefully. So, here, very small negative number will lead to very big negative number. So, this, same over here, that. I have to somehow pass through here.
So all the same, right?
Scale, I've not been friendly to myself. And there.
Oh my god.
I've made this harder than I needed to be honest. Okay.
Straight lines get saved to this step. Yeah, that's my question.
So fx equals -1 and 1 on fx equals fx, right? Same over here. So when it's -1, blue and red meet. What is this value here?
0.
No. Oh no, it won't be 0.
Tiny.
Like half or something?
Oh no, you don't know.
Quarter? Something like that.
-3. You're pointing at -3.
It's not -3. It's related to that, though, isn't
Minus
it?
a third.
Good.
How'd you get that? Guess.
Why did you guess that?
Because I looked the reciprocal.
It's the reciprocal of -3, right?
Oh, when x is a third.
What's this point here that I just coloured in a bit?
The vertex. Closest to the axis.
Not 1/6.
I'm just confused what that line is. Like, what's the point of it? What's this upside down? Yeah, is that
That is 1 on fx. The red stuff is all 1 on
so
fx.
that's the opposite of the parabola.
Yeah.
Okay, that makes sense. Do you need
What is the value of that
Just literally drawing the
point there?
parabola.
Basically.
Oh, negative
Is that the vertex?
4 on. I don't know.
1 on 4?
Good.
So it's a reciprocal of the vertex.
It's the reciprocal of the vertex,
Oh,
right?
okay then.
Oh, okay, that's fine. Okay.
So you're picking on your key points, right? Your intercept, your vertex, your infinities, your ones. You're drawing through there and then just smoothing it out, right? It's kind of the idea that in maths, if something appears to be smooth, then it should be smooth.
So you're always going to have the parabola and then.
Always is a stretch, but yeah.
For now, we're always going to have a.
Basically, most of your curves are going to be made up of things that look like part parabolas. Be careful about using the word parabola. It's not a parabola. Why not?
Because it doesn't.
Doesn't what?
It doesn't intercept the x.
Well, he doesn't keep
Yeah, it's got asymptotes that stop it, right? Parabolas have infinite domain. This is not one of them, right? It looks like a parabola. It's fine to think that way, but just be careful about language.
What's it called?
Part of the
Upside down
curve,
curve.
1 equal 1 over fx. It doesn't have a name as such.
So that.
And then
also
things that
counts
look
as
like
asymptote.
hyperbolas, right?
So nothing can touch the asymptote.
No,
But
asymptotes
then
are
I have to
untouchable.
hold-
Horizontal asymptotes are a different story. Vertical asymptotes are untouchable.
Yeah, that entire page. Yeah. I have a question.
Yeah,
What was the minus third?
that's the I took the reciprocal of the intercept to find the other intercept.
So that's the intercept, okay.
Yeah.
So that would be 1. No,
Is that the domain?
So what's the domain and what's the range?
Negative infinity to -3. Open bracket.
Yeah.
And then -3 and 1.
So the domain is negative infinity to -3 union -3 to 3 union.
Isn't it -3 to 1?
Oh, thank you. Yeah.
And then
What's the range?
everything but 0.
Not quite.
So you finding the domain
Oh,
of
it's just
both
like it can't
graphs
equal
No, just of FX, of 1 on FX.
two.
just to.
Isn't the range infinite?
No.
No,
Hang
because
on, I missed that. Sorry.
0. It can't be.
Oh, it's negative infinity to minus 1? No. 4. That's definitely wrong. What if?
Sorry, what?
So,
So these are for both parabolas, right?
no, just 1 over FX.
And the hyperbola.
So it's just the negative. It's just all the red lines.
Yeah. Right.
Okay.
So the domain is hopefully reasonably obvious. It's just the asymptotes are a problem, right?
Yeah. Oh, so it just can't be
3 or 1. Minus 3 or 1.
So can I say x cannot equal
Yeah.
3
Yeah.
and x cannot equal 1?
Yep.
Oh, that's much easier.
Yeah. Would I get marked down on that in a test?
No.
Can you do this algebraically?
No.
Minus 3, is it?
Ooh.
Oh, no, we shouldn't have to.
So you can't use algebraically.
Not really, no.
So then what do you do for range?
But the thing you have to realize is most of the questions you're actually going to get are going to be that, where they give you a picture, not an algebraic
Sketch the
expression.
reciprocal.
Yeah.
So it's literally just the opposite. You just.
I just didn't get the range.
So look at the top, it goes from infinity down to 0, right?
Infinity, yeah.
And then at the bottom, it's hard to see, but basically you can't do this bit here.
So you can't be.
Between 0 and... I knew that would happen.
On the top section, why is it 0 to infinity? Isn't there like it kind of like not hit 0?
It's like open bracket, so it's not open. So you can get really close to
There we go. Say again.
I think I've got it. It's okay.
Okay.
So the range
Yep.
is negative infinity to a negative quarter. Yeah, I'm a little bit lost on this.
Yep.
And then we do these ones.
Yep.
And that's just can't be 0.
Yep.
So you do curly brackets 0 infinity.
Yep.
Oh my god.
We're not in year 7. I don't tell you how much space you need. I don't tell you to draw a margin.
Oh, it wasn't expected.
All right. I'll pause the recording now.
Oh, it's just yeah.
Girls, let me just quickly... Let me just talk through Anna's solution. I know I've probably said this to most of you, but we'll just say it again. So, important things, and there's actually one small thing that's been left out here.
Anna.
So, you draw your asymptote lines where it's 0, you draw your 1s and your minus 1s if they're not there. The point of the 1s and the minus 1s is wherever the one line meets the old curve, then the new curve should go through there too, right? So you can kind of start by drawing your dots through there. Then down here, for example, it's 1 over 0, so it's going towards the asymptote. But, I mean, you know you've drawn an asymptote, so you know your curve is going to head towards the asymptote. So you're just thinking, is it going to head towards there and be positive, where the number's already positive, or is it going to head towards there and be negative, where the numbers were negative, right? There's one other thing that is not on here that I'd like to be on here. Can anyone see what it is? Yeah. Basically, if you're given any numbers, they should be reflected in your answer, right? So basically, any numbers that you're given on the curve, you should show the reflected version of in your answer.
It's like, see how they gave you minus 3 as the intercept for the parabola? Because that line is the reciprocal of the parabola, it's negative.
Yeah.
Isn't it?
Wait.
Wouldn't it be a third?
Yeah, we need to wait.
Reciprocal just means put on the bottom. It doesn't mean make it negative.
I'm not
What are we
negative,
finding
I'm
the
thinking of
reciprocals?
perpendicular.
All the y values.
So
I'm thinking of perpendicular.
Yep.
why would you
That's
know?
what I'm thinking. And then I'm also thinking like, I don't know.
What is minus a third? What is minus a third?
It's a reciprocal of minus 3. So it's the y-intercept. It's the new y-intercept.
What point on the graph is it?
The new y-intercept.
Why is there a y intercept?
Because the old y-intercept was minus 3. So the new one is going to be minus a third.
Oh,
Yes.
So if
Everything.
I were to draw the second one,
Yeah.
say 0.11, the same point would just be the same point.
Yeah. So it should look like this.
Yeah, how does it look like that?
I don't know how to do the range.
I know that they're -1 and negative whatever is the same. Like those 2 points are the same.
Okay, I'm gonna do another one.
That's as far as I've got.
Okay, how about we talk about this one together?
Can we talk about the range?
Just the range.
Oh, the range of this
I
one.
don't know how to do that.
Okay.
Yeah, I don't know how to do the domain either.
I know that it's
Domain.
So the range is y is less than 0,
yeah.
or y is bigger than or equal to what?
1.
1.
Oh.
Hang on.
Okay, yeah.
What do we do that?
I mean, basically what I did was I looked at the curve and I said, where have I drawn it? So I've drawn it everywhere below the axis, so that's less than 0. And I've drawn it from 1 and above, so that's greater than or equal to 1.
So y is less than 0.
Yep.
Y is bigger than or equal to 1.
Yep.
And the domain you can just do x is not 1 and x is not 3.
Yep. Did you have a question, Rose?
I was just wondering, with like the one before,
Yep.
the vertex is like at -1/4, but how do you know it's like they have the same
Because they're 1.
lines?
So before it was a quarter because the old vertex was 4, right? So you do 1 over 4. There it was 1, so the vertex is 1 over 1, which is 1. Yep. All right, let's do the next one together.
Should we draw it first?
So firstly, all my asymptotes are going to go in.
Oh, should I draw this?
Oh, I know what it looks like. No, I don't. I totally just. So it can't cross the asymptote, so it's really condensed.
Yeah, it's quite condensed. There's a lot going on with this one.
Yeah. Oh my god. Oh yeah, I forgot that.
Okay. Now, you can, at a certain point, you can get confident enough to remember a little rule of thumb, which is a little bit of a closed parabolic bit turns into a big parabolic bit, and bits that go on forever turn into hyperbolas, right? But I'd prefer you to actually do it properly. So
We need to write down all those points, don't we? Really?
you do, because they're 1, right? And 1 is important. I actually don't need to draw in any 1 lines here because all the 1s are given. If you drew them in, it doesn't matter. All the 1s are given, which just means that everywhere that they've kind of coloured in a point, my new curve should meet that coloured in point.
So I have one hyperbola up here and one down there.
Yep. And this, just to be clear, in the exam, likely most of the questions you get will be a version of that that's half a page big, and I'll say sketch over it 1 on FX.
So in this case, can we still
Makes me.
technically, if okay, how do I say this? Can we just not draw them and then just draw the 1 lines?
If you wanted.
Yeah.
Yeah.
We'll do both.
So that's right. So I'm drawing the 1 lines as well.
You can if you want. I am.
No. I like the 1 line. I actually understand how to do that.
No,
Take 1. Why?
I don't think so. I think you went through the x-axis, didn't you?
No.
Oh, okay.
The X on here, that's the X.
Okay, yep. Then it looks okay. So this is going to be quite hard to draw and draw accurately, but something like that.
Where are the 2?
Sorry, so
I can't even. Oh,
No, I didn't go through that.
so you're drawing the lines on -3, okay, yeah.
Oh, that's okay. And all I have to do now is
I'll go and shove it in Desmos actually, because I can you kind of know what that is.
so the domain, the range, and then
I'll change the numbers a little bit, but
And do I have to give, so -2 would be -1/2. I feel like is that right? Wait, what? So what's that?
Oh yeah.
-2, 1, that way.
That is always not 0.
What's that? -1/2.
no, it's 1. You're not flipping, girls. The -2 bit in the x coordinate. A few of you are having trouble with this. That never gets flipped. Right? It's not the x that flips. It's just the y bit that flips.
Also, all of it, the whole thing is just 1s and -1s.
Yeah.
Oh, so I don't have to give any points at the end.
Okay, I'm recording, and I'll probably record the whole of it so you can look at it on YouTube later. I'm gonna just see if I can get this to live in Desmos so we can see it there.
So would I have to give those points, considering they don't change? Would I have to draw them all twice? You know how you already labelled them, you have to draw them all twice? Yeah. The points don't change.
Yeah.
You You have to write them again.
Say it again. I was just saying yes.
So you know how in when like the original, you know the original one.
Yeah.
You're on your period?
Yeah,
So when you have
Girls, you know I'm recording.
you know the original one.
It's okay,
how
Daisy,
the
you're
point
right.
and all the second ones. They're all one or negative one. They're negative one and they're one. Do I have to write those points in that they've given us, or they'll be there already, and then write them again?
Well, you're drawing on top of it.
Exactly. So I have to write them again.
You could go back to the actual drawing draft.
Yep, just let me talk through this. This is actually the same. So it turns out that they picked something fairly easy. So this is fx, right? So now I'll just, to convince you that what we're doing is correct, I'll draw 1 over fx. Right? So that is what we just got, right? So I'll draw in the asymptotes. Oh, actually, I won't draw in the asymptotes. Oh, maybe I can. So there's one of the asymptotes. I won't draw the other one in, just because it'll get quiet.
Oh, so the range is now everything to 0.
Oh no, but then from 0 to 1. Oh no, you're right.
Yeah. Yes, I got it.
And then the domain is not equal to that, or that, or that.
So it cannot equal minus root 3, 0, or...
Root 3. Yeah.
With the, you know how, I literally can't find words. The blue parabolas, like the double.
Yeah.
See how they like meet at the same point as the red one, like on 1 or minus 1?
Yep.
How do you know when that happens? And when
If
it
they're
doesn't?
1. So if they're 1, they meet there.
Yeah, but
Don't know how to make them sync up.
no, but so.
Do you mean like, why do they meet there and there?
Yeah.
Because it's 1.
What? If the vertex is
The y value.
The original point.
then the other vertex will be
what
1
it
as
say-
well.
Oh, yeah.
The reciprocal is 1.
2.
Then this one would go up here,
Yeah.
and this one would come down to a half.
And if it was vertex,
Right, okay.
reciprocal.
And if the original was a half, then the original would go there, and the top one would only come up to 2.
Okay. And what you're doing like that is you're just
Unless it's minus 1.
Yep, I'm just flipping them, whatever they are.
Okay.
Yep.
Okay, I have the next one, please.
Any other questions about that one? Yep.
And since they're all one, that means that the vertex, when we put it, is just the same point.
Yep.
And then what would the domain and range be?
So the domain is not the asymptotes, and the range is not 0.
I thought C turned into D for a second and I thought I was losing my mind.
Why is the range just not 0?
Basically,
Everywhere else?
yeah, because it's drawn everywhere else.
Okay, so it's just like where we are.
So I was like, okay, finally I have a more space.
you don't think that was obvious.
Yeah.
Are we doing C? Yes.
Okay, what's 2 doing? Oh, it's just letting me know that goes. This what? Okay. 2 really angry. So does this never touch 2? Is that what you're telling me?
No.
It does touch 2.
Like, it goes through a half. Flip 2, you get a half, right?
No, no, but you know how it's got like the actual line that they've already drawn?
Yeah.
See how it's got the arrow and it's like deliberately not
Oh,
touching 2?
yeah, that's a horizontal asymptote. So there'll be another horizontal asymptote somewhere. Yeah.
Oh, so then it's negative 2, isn't it?
A half.
Negative half.
Positive a
No, not
half.
negative, just a half.
Positive.
So in this case, are the asymptotes still 1 and negative 1, or are they?
1 and 3.
Oh my god. No, on the X.
And then about.
Wait, do we not do it?
Yeah, I'm doing C. But with the, like, would you draw the 1 and 1, negative 1 line?
Yeah, you could. Yep. You don't have to draw the negative 1 line because it never reaches it though.
Delete this. Spiritual signal.
Yeah. I just feel like I'm a PDH student.
Well, it's already touched it.
That's an asymptote, like isotope.
I was saying, but
Wait, so it's
Dr. Manuel, it's already gone through the asymptote.
Horizontal asymptotes are different.
So the ones you draw from the original.
I think there's another.
That's the original.
That is, so you just redraw it bigger.
Okay.
Yeah.
Wait, so 2 is an asymptote.
So you can go through horizontal asymptote. Well, they can't be. Well, they're not allowed to.
The definition of a horizontal asymptote is only relevant for big X.
You don't need to know that.
Like really big values of X.
So it's irrelevant. I'm just like, no reason.
No, you need it for your.
So it's like you can't touch it.
Uh-huh.
I know. Name.
Is this right?
Oh my god, we think the same way.
So the asymptotes are 1 and 3
Something
and 0.
happening over here.
I don't know what that way is, but
Hey?
The asymptotes are 1 and 3 and 0.
okay, girl.
Zero's not
Okay, girl.
What's that number?
1 and 3, right?
On the bottom.
And the x equals
3. It's less than 1, I would suggest. Like, let's say it's a half.
Wow.
Isn't it 1 and 3? So I should call the half.
Because they're not-
Okay.
Oh, it's just
Oh my god, this is so.
Oh, is there any range? Is there any range of infinite?
So basically, you see
Oh,
here
why
how it
can't it equal
approaches
0?
2. What's it going
Is
to
that
approach
just the range?
on the other one?
Let me figure it out.
So you need it.
Yeah.
Just be like,
So the reciprocal, if I call in the bottom one negative a half, it's negative every day. So it's still negative 2.
Yeah.
So is it approach like
on the
Yeah.
left and the right?
No, just on the right.
Right.
do we need to find a way going like that?
No.
I don't know what to do now.
So, because they haven't drawn it, I would say it's less than 1. So just
What's less than 1?
the value of the vertex.
Okay.
So I would just draw a parabola like that.
Okay, but you just don't know.
I'm not giving a number because I've got one to start with, right?
So draw not asymptote for a half.
Yes,
Why would it not touch this? Because it's less than 1.
because it's less than 1. Yeah, so I'm saying that 1 is here somewhere.
Sophie. My brother's psycho girl. Didn't you like it? So then it would just look like that. So if it was 0.5. Oh, so that's what she's saying. What? Like I finished it. I had to go there. I was like,
Shh. Okay,
what are all of those?
Is my pencil round?
not quite. Very close.
So where can I cross? Which one?
You can cross this one to go to a half.
Oh. Because that's at 2, so it's...
Okay,
But the
let's
other side can only go to 2, can't it? The other side can 1.
go through it together. So I've drawn in my 1 line. I've said here, because they haven't given me a number, I've said that -1 is below the bottom of the parabolic bit, below the vertex. I just said that. I've just looked at the scale. They haven't given me a number, so I've made up my own scale. You're allowed to do that if you're not given a scale, right? And to me, look how big 2 is. That doesn't look like 1, right? So I'm saying that. So then I draw this parabolic bit here between the asymptotes. And, if that's a half, then this would be 2, for example.
Could you technically overlap?
You could. You wouldn't be wrong. You just have to show where 1 was then, right?
Why are they so far apart?
Well, like, if this is negative a half, then this is 2. So they should be reasonably far apart.
So all it has to do is hit the -1 line.
Yep, and the 1 line.
Wait, why'd you do another asymptote for a half?
We'll get there. Okay.
So the parabolic bit on the bottom, the vertex should be at -1.
-2.
The vertex should be wherever the vertex for the other thing was. So they should line up.
Right.
And they do.
So that's all you need to worry about.
Yeah. Do you want to wait a minute so I can finish this? Yep. So if they go through the 1 line, right? They go through there and there. This is an asymptote here, so it's going to do something like that. Over to the left here, so the reciprocal of 2 is 1/2, so I'm going to pass through there. Goes to infinity, so it's going to go to 0. So something like that.
So both
That's what
sides
I
are
don't get. That's why I'm confused.
Why are you confused?
I just don't get. So why is it supposed to be going that way?
Because over here, if I go to the left, right, the y value is getting increasingly large,
Okay, so
so the reciprocal will get increasingly small.
why does it have? It has to hit where the blue one is at 1, and then also crosses the y-intercept at half because that's the reciprocal of 1.
Reciprocal of 2.
But why reciprocal of 2?
2.
But why do they? Oh, so it's the reciprocal of the y-intercept.
Yep.
So how come we can cross those? Can you just cross them?
Yep. Is the short answer?
Why is it not on the other side?
Yeah, we're going to do that next. Okay. So, over on the right, so it's a positive thing, so I'll start here and go to 1. Now this one's new, this bit's new. So there was a horizontal asymptote at 2, right? So it never quite got up to 2. So now I flip that to 1/2, and now we're never going to quite get to 1/2. So now there's a horizontal asymptote at 1/2. Right, so if there was a horizontal asymptote at 4, then I'd have one at 1/4, for example. Right, you flip everything, including the horizontal asymptote.
But so how do you find the horizontal asymptote? Where that comes from?
It's the reciprocal of the other one, which was 2. And I know it seems weird that we've crossed the horizontal asymptote,
So I can't do that.
but the definition for horizontal asymptote is basically for very large x, so you kind of ignore it everywhere else.
So it's only applicable because on that side of the thing,
Yeah.
that one can't touch an asymptote, whereas the other side just totally ignores and goes through it.
Why can the other one touch it and one can't?
It's because, I mean, the short answer is because it can, because asymptotes only exist for very large values of x.
So
Vertical asymptotes are different, because that means, because remember, whenever we talk about a function, we're always saying f of x, so we start with x, right?
yeah.
So a vertical asymptote is literally, I can't sub in x.
Okay.
So there's a line there that can't be touched, because I can't sub it in. But if I'm saying fx equals 1/2, right? Basically what this curve is saying, that when x gets really, really big, fx gets close to 1/2, but it doesn't say that it doesn't equal 1/2 anywhere else, and you're allowed to do that.
Okay. So
Since the asymptote that we were originally given, the horizontal one,
Mm.
only one side could almost not touch it, does that mean there's always going to be, in the reciprocal, there's always going to be like one side that can't touch the other?
No, this is just the one with the horizontal asymptote. But I mean, think about it, you're probably going to get given one like this at some point, right?
Yeah.
Because I'm mean.
So I think you may have described this, but how did you find the -1/2 for the vertex?
Made it up. So in an exam, I wouldn't do that. I would just do
because they gave you
that.
They
I would just show where -1 was, right?
Yeah.
So all I really care about is I'm saying, because they haven't told me, I'm saying this is not reaching -1, because that means there's a gap between the original
So you
and
can pick a
the...
number really.
If they don't give it to you, and as long as you're sensible, yeah.
Okay.
Like everything has to work in concert. So I couldn't say, oh, this is
-3.
1,
Yeah.
right? Because it's bigger than 2, right? But yeah, within reason, you can pick your numbers. Brain break.
That was a good piece of
5 minutes. If you're leaving, don't distract other classes.
Oh wait. 7
You can work
Seven
through
or
it.
seven?
But also, I would encourage you to, these are from a different textbook that I pulled some questions from, right? And there's also, there will be some on here that would be relevant as well.
Will you be able to do these? Or?
Yeah.
7 seconds.
You'll probably need some help, but you should be able to try them.
And it's exercise 7
I hate not having answers when I'm reading all of
Exactly. Yeah.
Yeah.
You don't have answers in the tests. You don't have answers in the tests.
You believe me? At least I know.
Like, do you really want me to go through the whole exercise? The whole
You're not going to be
exercise?
completely wrong. All right. Absolute value functions now. So
Is this extension?
this is all extension, yep.
If this was meant
So we know.
I'm gonna go home.
Why are you going to cry?
This is so hard.
Oh, it's fine. You'll get there.
I'm not gonna cry.
So we know that absolute value function means make things positive, right?
Yes.
Yep.
I actually do know that.
So what do we think that is going to happen when we sketch now y equals absolute value of fx?
It will just always be positive.
It'll always. What does that mean visually?
It will always be on this side of the. So the range will never be less than 0.
Always up here, right?
Always above x.
Yeah. How do you think we're gonna?
Exponentials.
How do you think we're actually going to do it? Like if I give you a drawing and I say draw the absolute value, what do you think you're going to?
Just cut it out. You draw it and then white out the.
Table of
It's just gonna roll
values.
around.
We're definitely not doing a table of values. We don't white it out per se.
Just disregard it.
No, you don't disregard it either.
I like table values.
Yeah, same.
What's the absolute value of -1?
1.
So when the original curve was -1, shouldn't it now be at 1?
Oh, that's. So you reflect. It's just.
Yeah, you reflect,
You
right?
only reflect the negative part.
Good. Okay,
Yeah.
finished, done. We don't even need to do it, right?
Oh,
Yeah.
We will do it, of course. But
Okay.
so what about this one?
Same thing. Same. No, but it's.
The absolute values are in a different place. Surely it's a different thing.
No, but it just means x. Oh, no, it's the same. The function of
If
just
if
x.
you make the whole function negative, then
So what? If, no, but if f's negative, it can be negative. Jokes.
Yeah, the function can be negative. What can't be negative?
X.
The input. So x can be negative, but the input can't be negative. So does anyone want to have a guess at what's going to happen?
it's all
We'll
gonna
draw
go
the
over
axes.
positive.
Always gonna be positive.
The x values will always be on the right.
Not quite. I will actually be able to draw it on the left. What will be the relationship between what's on the right and what's on the left?
Reflected.
Close.
Refract.
Mirrored, right? Symmetric, right? So if this,
What's the difference between reflection and mirror?
well, to me, a reflection implies this, and then it's not going to work because it's not see-through, but then that. So everything reflects. But symmetric implies I do that, and then I do it on the other
That was
side.
the last question on the 2020 paper, and I was like, what?
Do you see what I mean? Yeah. Does everyone see why that's the case? So the idea is that if you've got an input of, oh, it looked better.
If also with the pass table, do we have an extension pass table without answers? Is that somewhere that I just haven't looked for it?
Without answers, what do you mean?
Because you know how you put up the extension paper on
Yeah.
OneNote with answers.
I'll go to Canvas. They're on Canvas, the actual
The
papers.
paper without
Yeah,
answers.
yeah,
The extensions.
yeah,
of it.
yeah. So the idea is if you've got the value of the function at 2, it should have exactly the same value at -2. Right? And that's the same for all values. So I think this one, I'm not surprised, is going to be easier for us. Right? Let's see.
Let's see.
So let's sketch this.
Wait a second, I'm drawing my W.
I thought.
So what does that look like?
So yeah.
Through
Where's the absolute value?
Through
a line?
3 and 0.
3 and 0.
That just is like a normal one. I could do that.
Smiley face.
It's a parabola. Yeah. And the step is -3.
So that's fx.
And the y-intercept would be
0.
no intercept, yeah.
Goes through the origin. So theoretically, I should find a third point, but I'm not going to bother, to be honest.
Why? What third point?
Any third point, but parabolas need 3 points to be completely defined. Because I can draw another parabola through those points that's different, right?
So with the vertex, would you go...
Oh, you can.
Daisy is confused.
1.5.
Is she watching it as it goes, or is she watching
I feel, is this
Oh, but she can't hear it.
Should I
Tell her to wait for a video. Yeah, there's a video.
Oh, she's watching the one.
Oh
Oh my god, she would be like, what?
That would be so good. Did she go record? Don't. Listen. Don't listen.
So I'll leave that there for a while so she actually sees it.
There are so many lines everywhere.
Yes. Can you imagine trying to learn this just by watching me draw? Like, oh yeah, and then this, and this. Right.
That's actually what it would look like.
Yeah, you just be like,
Be like, oh, here's another dotted line. Here's another watch. I'd be so confused. Oh,
so. Alright, so now we've got to sketch absolute value of fx and f absolute value of x on the same axes. We'll use 3 different colours, obviously. So what does the absolute value of fx look like, do you think?
So only in the top. Just those top two. And it's a parabola. Isn't it just?
No, you put the curve at the top. You put the opposite, like I don't know.
Yeah, it's just
Yeah.
that.
Wait,
But
is
then
it
you
just?
also have to do that.
Oh.
Yeah.
Oh no, I totally get this.
So everything that was there, make it positive, right? These bits were already positive, so they should be exactly the same.
Oh, yeah.
This bit was negative, so just flip it to make it positive.
And we don't have to be exact if we didn't find the vertex.
Nah, yeah,
But you can find the vertex, can't you?
yeah. But I'm not
Should we find the vertex?
not too concerned with that, to be honest.
The vertex would be.
The vertex is there. How would you do the opposite?
It'd just be like,
Oh, just be like,
This is just
The
not
vertex would
if
be
it was
3
negative 3 to be
squared.
3 or something, right? Yeah.
Well, that's an absolute value.
So what's this one look like?
What do we think the second one looks like?
The exact same but reflected.
Close. It's the exact same on the right.
And then
What happens on the left?
it does the W. It's a W, isn't it?
oh, it's just. I think it just stops, doesn't it? What?
So everything on the left, there's a mirror here, right? Everything on the left just gets pasted onto the right.
So you just disregard the line that's already gone onto the left.
Didn't we technically make? Isn't X still negative?
Yep. But then you absolute value it so it is positive.
So I can just tell if it's
Okay,
positive
so
or not.
do I need to understand that or can I just like do it?
I don't think
So like this. It is. That's why the little thing isn't there, I think.
Oh.
So if you was like in to get like get like
Yeah, still going.
draw f brackets absolute value x, would I have to go over the whole thing or can I just draw the extra part on the left?
You could just draw the extra part. Yeah.
So
And just kind of cross out
This keeps
anything.
probably mirror x, it doesn't technically make x positive.
Yeah, it does. Like, so this is what I'm trying to explain here, right? So f of absolute value of minus 3, which is where should I draw the curve for minus 3, is the same as f of 3. So it's the same as that. So it just gets pasted over there.
Okay, so that kind of makes sense.
And you could do that with any number, right? But it's obvious.
why is it
Are they the only
So
two like
see how the first one you actually mirror the whole parabola kind of
Yep.
from the the negative beat flip. Why isn't there like a line, 2 lines going side in the middle?
Because so the idea is that you can never actually get here. So this is what happens if you do f of minus 1, for example, you get there. But you can't put any x values in to get f of minus 1 in this example. So that's why this bit never appears, because you can actually never achieve that. Okay?
So will we get like a f and then
Yep.
brackets absolute value
7 minus 2 plus 2, like
Like-
more than 1.
Let me just quickly flick through these. Like these are past HSC questions, right? So first one, multiple choice. It's like this is this, which one is this? Same with the next one, multiple choice, right? And then if you turn the page
Oh,
over,
these are the easy questions.
no.
Is a lot of it multiple?
Here's the graph, draw these things, right? That one there I'm looking at. So
Is there a lot of multiple choice?
it's 10 multiple choice. I mean not in your one next week, but
No.
in the final it's 7 choices, 10 of which are multiple choice.
Is there any multiple choice?
Yeah, there'll be like 3 or 4. Yeah.
And the week after?
Yeah, that's what I said. I was talking about that one.
What about?
I think there's going to be more in that one probably, but I'll,
Has that been written yet, or are you just not yet?
yeah, mostly.
Are you writing? I'm just done.
She wrote like the first bit and then I edit it kind of thing. That's how we do it. One person starts it, the other one finishes it. We take turns.
Just keep in mind.
There you guys suck? Yeah, okay. Oh no, that was still recording. Okay, try those ones.
Yeah, I think I love it. Think about this. Oh, yeah, no, it's
Wait, so you just we need to range brackets, absolute
No.
value of x brackets again. I just isn't that like that's going to be positive as well? So isn't it exactly the same as that one?
Yep.
But why is it 2?
Oh, so the difference is what is positive. So in this example, the input is positive,
Yeah.
right? Which is why you just get this positive bit repeated twice. In this example, the output is positive. Oh, sorry. Which is why everything should be positive.
Okay. But why are you repeating this one twice?
Because that is f of x, and then where the negative x values are, you should get the same thing. So it should look exactly the same there and there.
Okay. And that one always is just like the positive.
Yeah, you just make it positive.
Okay, I get that. Thank you.
How is this part positive?
How was that part? Sorry?
How is that part positive?
It's not positive, right? The inputs. So for your yellow one, it draws fx and then makes fx positive. For your orange one, it looks for an input, and no matter what it is, it makes it positive. And then you switch it. So like negative x value should be the same as the positive x value. Like plus is 1.5, and that should be 1.5 as well. So here, these should be the same. Does that make sense? Alright, I'll do the first two.
Okay, ask you questions.
So I'll do f absolute value of x in
I also have a
blue.
question with complex and word. I think I am correct.
Oh, it's different lines for your
Pink and scarlet.
It's like $2,000 alone.
I'm gonna
I think I might be
enter
right.
it to Elena because then we have double the option.
Yeah. It doesn't. Did you go like,
There are the first two. Oh, why is it? Sorry, I thought I was unfrozen.
Yeah, but we have to have a contract to make sure they always get the document. Okay. Yeah, I got
They
that.
can keep 10%.
Why did I? Yeah, I don't know.
Oh my god, stop! The dollars and Alex Gailey.
Three ladies.
That is the other. Oh, that makes me so proud.
Where's the rules at? Why is there rules?
And then that's how I want it.
What is wrong about my graph? I don't understand. Okay, just redo it.
Which one?
The pink is this one.
So it's the left is good, but the right shouldn't change. Because if x is positive, nothing changes, right? Over here, x is positive, so nothing should change.
So it should just be.
Yeah, it should just be that and then mirrored on the left.
Oh,
Okay, how do you
so the right is.
Oh, actually, now that I've done this, I can probably.
Yeah.
It's literally the same as your.
Hold on, is this right?
Oh, idiot.
I feel like it's just W.
Yeah, it should be W's. Yeah, sorry.
This is right for the last one.
You've done this. Which isn't in the syllabus. Used to be.
I'm just found it.
Yeah. Yeah.
It's so sad that you just totally disregard the left-hand side when you're doing your reflection.
Oh, that poor left-hand
It's
side.
irrelevant, like so
Oh,
irrelevant.
that's really.
Also, for the when it's like the absolute value of just x,
Oh,
you only reflect what's on that side.
This one is so much.
Say again?
For the absolute value of x,
Yeah.
you only reflect what's on that
This
side.
one is so much.
The left might as well not be there.
Okay.
The last one was just.
I like this. This makes me like these.
So you got to finish on a high.
I like this. Yeah, don't bring us back to the 620 line.
I won't help you with any problems that you have in
How
that one.
many questions do you think will be like that million line graph now? Exactly.
Wait.
Oh, one.
Oh.
Maybe two. Maybe a multiple choice and a long
Why
answer.
is it choice? Like that was the worst experience.
Why does it literally only go like that?
What is this?
Because you only reflect the bit that's positive, right? So you take the positive x values,
Well, how are
Right?
you doing that? I have
Yeah, sorry,
and then you reflect them.
pages.
You ignore everything else.
Is it just positive too?
Can we scroll down a tiny bit?
No, like, yeah, it's fine.
Like, so you're reflecting that.
Yeah.
I mean, neither can I.
And you're going like that.
Yeah, for the purple, right? You're taking purple. Again, you can never get there because f of absolute value of x, that bit is like positive always. So you can't get to f of negative 2, for example.
We need a fun Dr. Mendel's boy.
Okay, so for this, for the last one, I want to graph it. I've got to find the like the 3 zeros and negative 3, 2, and 5. So how would I know if it like which way? Like,
It's a positive cubic, so it starts down and ends up.
I did that. So I had like this part, the 2020 past paper, the last question.
Yeah.
It was like, do find the zeros and graph it or whatever. I did that, but then it like it went up again because we get an even function.
Okay.
What? But it was like, isn't it supposed to go that way? Because like it's like.
So a cubic, like a positive function always ends up there, right? And a cubic has 2 places that it turns, so it has to do that.
For it to be positive. Yeah, but it goes even, so it did a W.
Well, that's a quartic, that's power 4. It's got 1, 2, 3 places that it turns around.
So if it's got 2, it's a cubic. If it's got 3, it's a quartic, and so on.
Well, look at the power of x. There's 3 x's, so it's a cubic.
Do you not need to like write any of the
Y values? Nah, don't worry about that.
like any? Do we actually?
Yeah, just worry about the x values, basically.
And it took okay, yeah, it took wow. Okay, I haven't started. Okay, so now
Would you ever make us give you values for this, or would you just say?
You probably want to include the x, the y-intercept, which is massive, so I should probably redraw it.
Dr. Mania.
Yeah.
You've done that. Oh, yes. Why don't you repeat it? For C.
Say again.
What, the green one for C? Why don't you repeat the
Except the y-intercept. How did
Yeah.
you find the y-intercept? Make x 0.
5 times 2 times 3.
I have a few questions about this. First of all, how do you know that it's positive? How do you know that it's ending up there?
It's positive x cubed when you expand it.
Oh, sorry, I didn't see that. And then also, how do you find the vertexes or the y?
Nah,
Okay.
just the y-intercept is enough.
Also, should find the y-intercept.
Yep.
How would you do that?
Sub in 0.
Okay.
Really appreciate this. Oh, 7 and 9.
Can you explain that green line?
How do you know it's going?
Yep, so I take the... So for the green one, I take the part of the curve that is over here,
Oh, so you're literally just, yeah.
and I reflect it.
Got it. Okay, and then should you draw in the intercepts, yes?
Yeah,
Totally. Okay.
yeah. You should draw in anything that you know. For yeah, I'm just stopping the recording. So that'll do. Bye.
And that's for